Hi class, we have the 20th lesson for logarithm. This is to solve an equation. The equation reads log x plus 9 base 10 equal to 1 plus log x plus 1 base 10 minus log x minus 2 base 10. Alright, we want to solve the equation here. But for any logarithmic equation wherein every base or all the bases are the same, we can regard it to be one of the easiest logarithmic equations for the bases to be the same. Only that there is one number here or one term that doesn't contain a log, but we can give it a log. Yes. So what do we do? We can say log x plus 9 base 10 equal to the one without a log, the term without the log. What do we do exactly? Ask yourself, what is the neighboring base? Base 10, base 10. So we say log 10 base 10. Whenever you want to give a non-logarithmic term, you want to convert it to logarithm, the desired base is what you use as the number and the base. If here is base 5 or base 3, you say log 3 base 3 or log 5 base 5. And the particular value that we have there is serving as what? The power. So this is plus log x plus 1 base 10 minus log x minus 2 base 10. So here continues with x plus 9 base 10 equal to, you can see base 10, base 10, base 10. And there is nothing in front of any of the logs here. So we can consider one base. Yes, 10 to the power 1, of course, it is 10. So between this log and this log, they are connected by a plus sign. A plus sign means multiplication. We multiply the log numbers. So 10 and this one is 10x plus 1. Yes, and between this part to this part, they are separated by what? A minus. That one simply means a division of x minus 2. I hope it is clear. Okay. So, one term equals to one term. One log equals to one log. And the bases are the same. So, this drops this one. So, we are left with x plus 9 equal to, this one will give us 10x plus 10 times x is 10x. 10 times 1 is 10 over x minus 2. Can simply give this 1. I hope it is clear. All right, so one term equals to one term. So if you have an equation where one term equals to one term, and there is at least one fraction for one term equals to one term, we can perform cross multiplication. So cross multiplication, this multiplies this. So we say x plus 9 multiplied by x minus 2. 1 times this is 10x plus 10. I hope that one is clear. So if this x multiplies x, we say x squared. X multiplies this, we say minus 2x. So we use x to multiply this and this to get this. Now it is time to use the 9 plus 9 times x plus 9x plus 9 times minus 2 minus 18, which is 10x plus 10. Is that understood? All right, the question is going now. Okay, so we say x squared minus 2x plus 9x plus 7x plus 7x. Here is minus 18. But before we write minus 18, let us bring this by collecting like terms now. 10x goes where? To the left. Minus 10x. Remember, on the right hand side, it is there with a plus sign. Switching it over to the left, the sign has to change. We are done with the x terms. This is minus 18. Minus 18. Do we need to change the sign of minus 18? No, because it is still on the left hand side. Now let us bring 10 again to the left, and this sign has to change. Minus 10 equal to 0. So x squared, this and this is minus 3x. This and this is minus 28 equal to 0. I hope it is clear. Good. Now, if you've gone through my algebra equations, we discuss quadratic equation wherein the highest power of the variable is 2. So what do? Let us ask ourselves this question. The coefficient of x squared, what is in front of x squared? Is it 1 or it is not 1? Definitely it is not 1. So that one is easy. So we simply think of two numbers we multiply to give us 28. The same numbers we multiply to give us 28 must be the same numbers we add or we subtract to give us 3. But considering numbers we multiply to give us 28, they are 28 and 1, 14 and 2, 7 and 4. These are the three sets of numbers you can multiply to give you 28. But among these sets, we are only interested in the set that we can either add or subtract to give us 3. Not only to multiply to give us 28, but adding them or subtracting them to give us minus 3. To give us 3. Now let's try the addition. 28 plus 1 cannot give us 3. 28 minus 1 cannot give us 3. So this is not a set. Let's try this one again. Addition. 14 plus 2 cannot give us 3. 14 minus 2 cannot give us 3 either. This is not also the set. Let's try this one. Addition. 7 plus 4 cannot give us 3. But 7 minus 4 can give us 3. So this set seems to be the set. Why I use the word seems? Because we have to endorse until after we have given them the appropriate signs. How do we give them the signs? First sign, second sign. The first sign goes to the bigger factor. Of these two, which one is bigger? 7. So it takes the first sign. For us to get this sign, what do? We say minus times minus. We multiply these two signs. Minus times minus is plus. We can check again to see if actually the factors are the right ones. Let's try the multiplication side. Minus 7 times plus 4, minus 28. That one is good. Okay, for us to check for this, we don't multiply. We read what we have. Minus 7 plus 4, minus 3. So these are the factors. So we have our two brackets like this. We say x, we say x. Why x? Because x is involved in the equation. So the factors are minus 7 plus 4. So x minus 7 is 0, x plus 4 is 0. Then x is plus 7, x is minus 4. The question is not just a quadratic equation. The question is what? A logarithmic equation. A logarithmic equation. So, having solved this one result into a quadratic equation, it doesn't mean that these are the answers or all of them are answers. It's possible that one or two are the answers. How do we know? We have a rule in logarithm that the log number cannot be 0. It can be 1 or greater. Yeah, it can be 1 or greater. So if it has to be 1 or greater, let's see which of these ones satisfies the how do I call it, the equation here. Now let's try 7. 7 plus 9, 16, no problem. Okay, 7 plus 1, 8, no problem. 7 minus 2, 5, no problem. Do you understand the point here? 7 minus 2 is 5, no problem. Now let's try minus 4. So 7 is okay. So let's start saying 7. Let's see if minus 4 also satisfies that. Minus 4. Minus 4 plus 9 is 5, positive 5, no problem. Minus 4 plus 1 is what? Minus 3. The logarithm of a negative number does not exist. So the fact that minus 4 plus 1 gives us minus 3, so it appears to be log minus 3. So that makes it impossible. I hope it is clear. All right. So even here again, so even if it only fails in one, we can say that it doesn't work. So therefore, we only consider the positive here. Not necessarily the positive, because that minus 4 doesn't alter this one here, doesn't disobey the rule. Yeah, doesn't alter anything here. So we can say x is equal to 7. Thank you for watching. Do not forget to follow, like, share, and comment. See my next video. This is very important. Having solved a quadratic equation resulting in something like this, you check to see which of them satisfies the logarithmic equation. See you in my next video.